Hello everyone, I am going to explain about trusses in this module number 3. Okay, so in this lecture video, we are going to see about trusses introduction. So what is meant by trusses? What are the trusses means? In the architecture and structural engineering, a truss is a structure. It comprises of one or more triangular units constructed with a straight member and whose ends are connected at the joints. It is referred as nodes. Okay, external forces and reactions to those forces are considered to act only at the nodes, and the result in forces in the members which are either a tensile or a compressive force. See guys, what the definition states means: a structure comprised of ends which are connected as a joints and nodes, and it's a steel members. Okay, it is connected comprising of one or more triangular units. Okay, it can be a joint using a welded or riveted joint or a bolted one. Okay, and external forces and reactions are applied to it, and steel trusses you can see in most of the auditoriums. Okay, so moments are explicitly excluded. Here we cannot see any moments because all the joints in the trusses are treated as revolutes, that is revolute joint. Okay, so now we shall see what is a truss. Okay, shortly, a truss is having three characteristics. What are the three characteristics means? It carries only axial loads. Loads are applied at the end points, and elements are joined by pins only. Okay, so this pins may be either riveted one or a bolted one. And another one more thing guys, it's an axial load, means it will be in the axial direction, and the loads can be applied only in the support, that is in the end points. Okay, so this is called as a truss. It will be having the steel stanchion. Okay, so here you can see a supporting one. Okay, so this is a steel truss. Okay, it is having, see, it is either connected in a rectangular manner. This is called pins. Okay, either it will be riveted or bolted or pin one. This is a pin connection, right? We can see the varying introduction series and types in the upcoming session. Okay, so these are all the various types of trusses. The first one is a open plane. Okay, and next one is a storage one. Open plane, a storage one, asymmetric one. Okay, double bobtail, a frame, and a purlin beam. Purlin beam means there will be a purlin will be there. Okay, and a king post. So king post is used in maximum of the auditoriums. Top hat and purlin beam. Purlin means it's another one steel support given in the beams. And queen post, this is called queen post, extended tie and variant one, and flat top if mono, and mono A, mono B, and inverted one. So these are all the varying types of trusses, right? So we can see about the trusses in detail. The first one is a planar truss. Planar trusses lie in the single plane and are often used to support roofs and bridges. See guys, this planar will be lying in the single plane only, and often it is used to support the roofs and bridges. In the roof trusses, the roof load is transmitted to the truss at the joints by the means of the series of purlins. In the roof truss, using the purlin only, the loads are being transferred to the bottom. Okay, so assumptions for the designing of trusses are as follows. The assumptions for the trusses are as follows. To design both the members and the connection of a truss, it is first necessary to determine the force. So you have to determine the force developed in each member which the truss is subjected to the given loading. In this regard, these assumptions will be, see guys, loads are applied at the end points and weight of the element is neglected, and elements are joined only by pins. These 3 points are seen in the introductory part only, but then again I am repeating that. See, at the end point of the truss only you can able to apply the loads. Okay, see, at the end point of the loads, and it looks axial load only. Okay, and see guys, you cannot apply in the middle, and weight of the element is neglected, and elements are joined using pins. Axial loads only. If the force tends to elongate the member, it is a tensile force. Where it tends to shorten the member, it is a compressive force. When the forces are elongated, it's called a tensile one. Shortened one is called as a compressive force. So guys, these are all the four assumptions which is used in the truss member. So for the truss member, there are different methods to analyze a truss. That is a method of joint and method of section using the three equilibrium conditions. That is summation of f of x equal to 0 and summation of f of y equal to 0 and summation of m is equal to 0 only. You can able to derive the what to say, like we can able to solve the numerical. So using these two methods, how to solve the statically determinate and indeterminate beams, we can see. Okay, see if you can able to solve all the unknowns using equilibrium conditions, it is called statically determinate structure. If you cannot join, it is called a statically indeterminate structure, guys. So I will continue in my next lecture videos. Thank you.